Okay, children, last the separation of mixtures, we'll study distillation. Distillation is used for what? Children, to separate two immiscible liquids. Yesterday I told one method. What is that method? Two immiscible liquids. Anyone?
Separating
Separating
Funnel.
funnel. But for two miscible liquids which are soluble in each other, we'll go for distillation. Two miscible liquids which are soluble in each other. Two insoluble means separating funnel. Two soluble means distillation. What is the principle of distillation? How do you do? What is the principle of distillation? Both of them are soluble in each other. Then how to separate them, children? Basing on their basing on their
density.
Density.
No, difference in boiling points. Difference in boiling points. Not densities. Not densities is separating funnel. Basing on the difference in boiling points. Okay, children. One will boil at 10 degrees. One will boil at 25 degrees. Suppose, imagine at 10 degrees, whichever will boil come out, that you will take it out, leaving behind the other one. Simple. So, children, I will give one small example, children, in distillation. I will give one small example which is there in our textbook, children. Separation of acetone from water. If you mix acetone, do you know what is acetone, children? Anyone in the class? Anyone saw acetone anytime? Acetone,
Yes,
anyone?
sir, it will be in nail
Nail
polish
polish
remover.
remover.
Very good. Nail polish remover. Okay, children. Nail polish remover. Children, take a mixture of acetone and water here, children. Okay, here is a condenser is there, children. Here is a condenser is there. Here is a condenser. Okay, and that is kept in another one, children. That is kept in another one, like this. And here you have to heat. Children, you are mixing this mixture of acetone and water. You are heating it. On heating, acetone has low boiling point. What is the boiling point of water, children? 100. But acetone has low boiling point. You have seen your children, your nail polish remover. As you open and keep, it will vaporize. Means its boiling point is somewhere around 20 degrees only. I think less than that point. So on heating, whenever the temperature here is attained 20 degrees, what happens? Acetone starts coming out because its boiling point is 20. At 20 degrees, acetone will boil. After boiling, that acetone will come here, and this is condenser, children. This is called condenser. Condenser means it converts gas into liquid again. And what is a condenser? It converts gas into liquid. What is a
Liquid.
condenser, children? It converts gas into liquid.
Liquid.
All the acetone is condensed here. Again, liquid will fall here. This is how two miscible liquids are. And children, you stop heating, and here what is left over? Water. Who came out? Acetone. Why it came out? Because its boiling point is only 20. At 20 degrees, it started boiling and came out as vapor. Vapor condensed here, came out as liquid. At 20 degrees, acetone came out, condensed into liquid. Liquid came out and fall as acetone, children. Like this. This is separation of acetone from water, children. This is simple distillation, children. This is simple distillation. Fractional distillation. Do you know what is fractional distillation, children? Children, fractional distillation also same, children. It is used to separate so many miscible liquids or so many miscible liquids. So many miscible liquids also you can supply, or so many miscible liquids or gases. Okay, but what is the principle, children? Same. Difference in
Boiling point.
Boiling.
Boiling.
boiling point should be that boiling point should be more than 25 degrees. Children, the boiling point should be more than 25 degrees. If boiling point is, children, what happens? Sorry, if boiling point is less than 25 degrees, if boiling point is less than 25 degrees, if more than 25 degrees, go for distillation, happy. And here we can separate only two. But in fractional distillation, if boiling points are more than 25 degrees, then we'll go for fractional distillation. Did you study anywhere fractional distillation, children, anywhere in the classes?
Yes, sir, petroleum there.
Very good.
Petroleum.
Petroleum. We studied in 8th class. Petroleum. What did you study, children, in petroleum? Do you remember, children? In 8th class, you remember studied
Yes, sir.
different fractions will be there. Different fractions will be there. Okay, children. And all these fractions, children, here they will be sending petroleum. When they are sending petroleum, different fractions are maintained at different temperatures, children. Different fractions are maintained at different fractions are maintained at different temperatures. When petroleum is going up, Whosever boiling point is 20, that will come out here. Whosever boiling point is 40, that will come out here. Whosever boiling point is 60, that will come out here. Whosever boiling point is 80, that will come out here. Whosever boiling point is 100, that will go out. So basing on difference in the boiling points less than 25 K, fractional distillation column will have so many fractions. And distillation is always boiling points. Always boiling points. Okay, children. What is the difference in the apparatus? This apparatus and fractional distillating apparatus will same, children. Only see here. This is there, no, children. After this, here some glass beads will keep, children. Why do we keep glass beads, children? Why do we keep glass beads?
For fixation.
Why do we put glass beads, children, here? In this, we use only glass beads. The glass beads provide surface for the vapors to cool and condense. Apart from this condenser, this will increase the surface area. Means it will increase the surface area of condensation. What does glass beads? Here also they are condensing, no sir, means yes, but here they want sufficient time to condense. That's why glass beads. What glass beads will do? It increases the surface area of the time of condensation of the gas. It increases the surface area of time. The difference between this and this is here only glass bead is there, children. That's all. And fractional distillation is used to separate that liquids which has less than 20 Kelvin. Okay, children, I hope you understood. Those who did not understand, for fractional distillation, one more I will say, children. Do you know air consists of so many gases? What are the gases present in the air, children? Nitrogen, oxygen,
Carbon dioxide,
carbon dioxide, water, so many other gases will be present, children, but majorly nitrogen is present, children. Okay, so nitrogen, children, if you see, its boiling point is minus 196 degrees. Oxygen, if you see, its boiling point is minus 183, children. And argon is also there, children. Argon, its boiling point is minus 186. All are less than 25 Kelvin only. So subject it to fractional distillation. Subject air. If you want to separate the gases in the air, children, if you want to separate this nitrogen, oxygen, argon in the air, go for subject it to fractional distillation. What you will do, children? First, Joule-Thomson effect. You know Joule-Thomson effect, children? Anyone? In Joule-Thomson effect, first air is subjected to high pressure and low temperature. Can anyone say why air is subjected to high pressure and low temperature? Can anyone say why air is subjected to high pressure and low temperature? So that air becomes
Lighter.
liquid. Air becomes liquid. Children, if you take air and subject it to very, very high pressure condensation and low temperature, if you give, all the air which is a gaseous form becomes liquid. Now this liquid, what you will do, children? This liquid, what we will do? We will heat. When you heat it, slowly heat it. First who will come? First who will come outside? Nitrogen or oxygen or argon. Who will come first? Nitrogen. It has lowest boiling point. So first it will attain boiling point. First nitrogen will come out. Take that nitrogen gas, condense it, and convert into again that children. Nitrogen gas will be converted when they are coming out because we are heating. No vapors will come, children. Again vapors will come. That we have to condense and we have to separate. Then second who will come, children?
Argon.
Argon will come, children, because it's second boiling point. So same, children, vapors will be coming, condensing and convert. Then third who will come, children? Oxygen. Oxygen. It also vapors will be coming, condensed. Like that, using the difference in their boiling points, you are collecting nitrogen gas will come first, then argon will come, then third oxygen will come. Then you will get out, sir, who is coming, how it is coming, how we will know, sir? Simple, children. You will have a thermometer, children. Please try to understand. We will have a thermometer. Okay, thermometer temperature, children. First, when you put at minus 196 degrees centigrade, we put no one will boil except nitrogen only. Keeps on boiling, keeps on boiling, keeps on boiling, and comes out. When you want argon, increase its temperature to minus 186. When you want oxygen, increase the temperature of the liquid to minus 183. So you give temperature, they come out. You give temperature, they come out depending upon their boiling points. So children, distillation is separation of two miscible liquids or gases. Two miscible liquids or gases basing on difference in their Boiling point.
Boiling
Boiling
point.
Boiling point is which is less than 25 Kelvin. Which one you will use? Fractional
fractional
distillation. Fractional distillation, some of the famous examples are separation of petroleum, separation of gases in the
Gases.
air, like that, children. And for normal distillation, acetone from water is the best example. What is the difference between this apparatus and this apparatus? Glass beads are present. What glass beads will do? It increases the surface area of
This area.
condensation of
Condensation.
vapors. It increases the surface area of condensation. What glass beads will do, children? What glass beads will do? Yes, children, what glass beads will do? It provides more
It
surface
is
area for the vapors to cool and condense. It provides more surface area for the vapors to cool and condense. Glass beads will provide more surface area for the vapors to cool and condense. Okay, children, so this distillation and this is fractional distillation. Figures are important, children. If you don't draw figure in Sunday exam, I'll write I put wrong, children. I will not even show little bit compromising also, children. Compulsory you have to draw. And also separation of air, there is no diagram, children, but a flow chart is there. Compulsory you have to learn the flow chart. Separation of gases from the air is there in your textbook. Some page you check, children, I don't know. There is a table. That table compulsory you should draw. For distillation, how many figures are there? Two figures. One is for normal distillation, one is fractional distillation. And for the separation of gases from the air, you have a table flow chart. Compulsory you have to learn and you have to draw in the exam and ask this question, children. Anyone have any doubts, children? You can ask me.